Hi, in this video, we solve question number 22 of IIT JAM 2021 mathematics paper. Here's the question. A is an n cross n invertible matrix. C is an n cross n nilpotent matrix. X is a 2n cross 2n matrix given in block form, where each block xij is an n cross n matrix. And X commutes with B, which is a 2n cross 2n block diagonal matrix. Now each option claims that two of the blocks of the matrix X are necessarily equal to 0. In other words, we have to determine which two blocks are necessarily equal to 0. Now let us use the given conditions on the matrices and see what we come up with. Let us first recall the definition of a nilpotent matrix. Matrix C is said to be nilpotent if for some natural number k, C power k is the zero matrix. Now, what do we have? We are given that X commutes with the matrix B. So let us write that XB is equal to BX, which implies that write X in the block form. We have this matrix, then block diagonal matrix AC. This is equal to block diagonal matrix AC times the block form of X. Now these matrix multiplications can be carried out in the same fashion as you would do for 2 cross 2 matrices. So if you use the rule, A gets multiplied to the first column from right, you have x11 times A, x21 times A, then C gets multiplied to the second column from right, like this, and right hand side A gets multiplied to the first row from left, we get A times x11, A times x12, and C gets multiplied to the second row from left. Gets C times x21, C times x22. Very nice. Now we compare their each block, and what we get is x11 times A is equal to A times x11. Compare the second block, we have x12 times C equals A x12, and then compare the third block, x21 times A is equal to C times x21, and then the fourth block, x22 times C is equal to C times x22. Now let's look at the first equation. The first equation says that x11 commutes with A. So the only condition x11 has to satisfy is that it has to commute with A, and this condition does not imply that x11 should necessarily be equal to 0. For instance, we can take x11 to be the identity matrix, right? If we take x11 to be the identity matrix, it is going to commute with A, but x11 is not equal to 0. Similarly, x22 is not equal to 0. We can take x22 to be equal to the identity matrix. So now that we have this, let us look at the options. The first option is wrong because x11 is not necessarily equal to 0. Similarly, C option is wrong, D option is wrong. This makes B the correct option. Now we are not going to stop here. We are going to see the reason behind why B should be the correct answer. To do that, let us consider the remaining two equations and see if we can deduce that these two blocks, the remaining two blocks, are indeed equal to 0. Let's start with this second equation. Let me drag it here. Very nice. Now what do we know about C? C is given to be a nilpotent matrix, right? So C power k is equal to the 0 matrix. If you multiply the block x12 from left hand side, this is also 0 matrix. Now what we do is we write x12 times C and then C power k minus 1. This is going to be 0. Now we know from the above equation that x12 times C is A times x12. Right? So this times C power k minus 1 equal to 0. Now again, do the same trick. x12 times C, put it in bracket and write the remaining part, C power k minus 2. Now again, x12 is nothing but A times x12. So A gets multiplied twice. We have A power 2, x12 times C power k minus 2. This is equal to 0. Go on like that, and eventually what we get is a power k times x12 is equal to the 0 matrix. Now we know that A is an invertible matrix, which makes a power k also an invertible matrix. Now multiplying this equation from left by the inverse of a power k, what we get is x12 is indeed the 0 matrix. So we have proved that the block x12 is necessarily the 0 matrix. By using similar arguments, you can prove that the remaining block x21, is also necessarily equal to 0. I'll leave it as an exercise for you. This completes the solution.